Hello everyone, I'm Prasad from Structural Guide, Civil and Structural Engineering Knowledge Base. Today we are going to discuss about dynamic increase factor. Firstly, let's see what this factor is. Dynamic increase factor is a factor that is used to enhance the material strength parameters. This is done when there is a higher rate of strains. For example, when a building or structure subject to a blast loading, its stressors or strains change very fast. When a structure subject to progressive collapse or the sudden collapse, in this case also the stressors or the strain changing rate is very high. Due to this higher rate of change in strain, we can enhance the material strength. There are guidelines to be followed when we enhance in the material strength. Let's see how we can do this. Now, in this case, we can enhance the characteristic cubic strength, reinforcement yield strength, reinforcement tensile strength, structurally also yield strength and tensile strength. For bending, shear, and compression forces, we can enhance these parameters. According to the guideline given in the blast effect on building, the book blast effects on building elaborate or they have given a table for enhancement factors. For bending, you can see in this table, for bending, we can increase the characteristic strength by 25%. That is, FCU can be increased by 1.25 when there is a higher rate of strain. In case of when you design a blast building for blast loads, so that's a higher rate of strain, so we can enhance during when the blast loads are applied. You can increase the characteristic cube strength by 1.25. Similarly, for the reinforcement, when you consider bending, we can increase the characteristic strength by 1.2%, 1.2. Tensile strength 1.05. Structure is also, so we have some factors 1.2 and 1.025. You can read this book, Blast Effect on Building, published by May and Smith, for further information on this. In addition, I would like to draw your attention to the guideline, General Service Administration (GSA) guideline for progressive collapse. In this guideline, also they have given a table for material strength enhancement, for reinforcement, for concrete compressive strength, we can consider 1.25 factor. Reinforcement steel, tensile and yielding, they suggest 1.25. Now this is almost same as the blast effect on building guideline also. So concrete bending 1.25, here also concrete strength they have given 1.25, but reinforcement here 1.2, but in this guideline is given 1.25. There are some differences in these guidelines. In addition, now this blast effects on building is a bit old book, and GSA guidelines not that old. It's published in 2003. But there are modern research done for these enhancements. Now, according to the modern research, they have found that this factor can be increased further with the rate of strain. Way higher the rate of strain, higher the factor. So you may refer the recent publication for this when you consider or when you designing a structure. But better you have consider a firm reference when you apply those, because now research is some kind of finding, but we may not be able to directly use it. For guideline like GSA guideline or this book, we may refer most of the time. But other literature or the publication also you could refer and for getting an idea about this. Right. Thank you very much. We are from Structure Guide, so we are request you to visit our Facebook page, LinkedIn page, and website for civil and structural knowledge. Thank you very much.